Hey everybody, welcome back to the channel. Make sure to subscribe if you haven't. This has been a question that has been requested by lots of my fans, so let's get working through it. So first thing, well, let's have a quick read. So we are told that there's a wire and a bead of mass 0.5 kilograms inclined at an angle of 10 degrees. So as I'm reading, sometimes I just like to label all the things that I'm being told. So I know that here the weight is going to be 0.5 g, or we can also just write half g. And an angle of 10 degrees, that's already given to us in the diagram. To the horizontal, the coefficient of friction is 0.25, so we're going to need to use that probably. And a force of P newtons is applied at 45 degrees. So we've got P shown on the screen. Calculate the magnitude of the normal reaction. So there's going to be a normal reaction, R, given that P is only just large enough to stop the bead sliding down. So if the bead would be sliding down without this force, friction is going to oppose the motion. So we can label friction here as going up the slope, and we're just going to call it FR. And we know that friction equals mu R. Mu is 0.25. I'm just going to write as quarter R. We don't know what R is yet. And now we can just label all the other stuff in the diagram. So we're going to resolve the weight into two components. So this is half G cos 10. And then down the slope, half G sine 10. And we're also going to resolve the force P into its two components. So P is going to be P cos 45, and then this is going to be P sine 45. Okay, so because it said it's large enough to stop the bead sliding down, it means it's in equilibrium. So forces going up equals forces going down. So let's resolve parallel to the slope. So half G sine 10 is equal to forces going up, which is P cos 45, plus friction, which is mu R. So we're just going to call it a quarter R. That is going to be called equation 1. And then we're going to resolve perpendicular to the slope, and then this is going to be called equation 2. So in this case, we can say forces going up, which are these forces, because they're going in this direction, equal the forces going down, which is this. So let's label that R. Let's do down first. So half G cos 10 is equal to P sine 45 plus R. So what we can see here is simultaneous equations. We have two unknowns. The two unknowns are P and R, and then we've got P here and R here. So those are your X's and Y's in a way. This is just a number, this is just a number. Now, interestingly, in this case, we can see that sine 45 and cos 45 are actually equal to each other. You could also just turn them into surds straight away, just if you want to. And then there's lots of methods to solve simultaneous equations. I am going to use elimination because it looks like they kind of line up quite well with each other. So let's use elimination. Because the question is asking for us to work out R, we need to eliminate P, and we can do that just by subtracting. So half G sine 10 take away a half G cos 10. Now I'm just going to write this out rather than put it in my calculator just now. So half G sine 10 take away half G cos 10 is equal to, now this going to cancel out because cos 45 and sine 45 are equal, and then the coefficients are also equal, so that's just going to equal 0. And we are then going to get a quarter r take away 1 r, so it's negative 3/4 r. So let's put this in the calculator, see what we get. Okay, so 0.5 times 9.8 times sine 10, take away brackets 0.5 times 9.8 times cos 10. That's going to give you negative 3.97468, and that's going to equal negative 3/4 r. So then we're going to divide both sides by negative 0.75, and that gives you 5.29957 is equal to r, and then you just round it sensibly. Now these types of questions, usually you would round it to 3 significant figures, so this will be 5.30 is equal to r, and just put 3SF just so the examiner knows how you rounded it. Okay, hope that was useful. Smash the like button. See you in the next video.